A minute more till it's like 5:30 now, I guess. Yep, it is.
You want to start off, Bernie?
No, you do it. Go ahead.
All right, I'll do this one. Welcome everyone, Philly IETF114. This is the Dhcp working group. Here's the IETF note well. If you haven't seen it by Thursday, you're lucky, I guess. Please take a look at it and please read it if you don't recognize it and follow all the rules in it. Additionally, we ask that you keep your mask on if you're not presenting or actively drinking, doing any of those things. Everyone's been doing a great job this week, so keep that up. No, well, blue sheets. So if you're in the room, there was a QR code. It's gone now, but there's a QR code. Please, if you're in the room physically, just go to the on-site tool, click on it, and mark yourself as here. That gives us accurate counts for who's here. Note takers, Bernie's agreed to start him off, and I'll be filling in when he's presenting. But additionally, there's the Markdown Hedge doc notes. Feel free to add your own notes as we go through. We'll clean them up at the end. And Zulip and Jabber is kind of like a merge thing now. So if you're in the Meet Echo tool, there's a little chat bot. It shows up very nicely. So feel free to use that. And I'm Tim, and Bernie's remote, hanging out with us from lovely New Hampshire.
Hi there. I hope everybody's doing well. And I also want to welcome Tim, because I think this is the first working group meeting we've had since you've been chair. Is that correct, or am I misremembering?
No, you're actually right. This is the first one I've chaired. I didn't even think about that. It seems like an eon ago now. Yeah,
it does. And, you know, I don't know whether Tomek is around, but, you know, we miss Tomek and wish him well and thank him for his many years of service as a co-chair. So with that, I'll hand it back to you.
Awesome. Thanks, Bernie. So this is our agenda for today. We've got a little bit of the normal stuff going on, the chair slides. We're going to talk 8415 to Internet Standard is our second. Bernie's going to take that one. And then we've got distributed SR6 locators by Dhcp. Registering self-generated IPv6 addresses is our fourth one. And then we're going to talk a little bit about next steps at the end. So I'll do this one, Bernie, since you're going to talk a lot in a minute. So our current working group status is we don't have any working group documents at the moment. We finally got the Yang model through after some trials and tribulations, thanks to Ian. I don't know if he's online, but Ian did a lot of work for that to get that over the hump. But we did get it over. We have two related documents today that we're going to talk about. Both of them are on the agenda, so that's good. Milestones we currently have, and Bernie's going to talk a little bit more about this, is 2023 and March of 2023 for what we think the working group's going to do going forward. Does anyone have anything they want to change about any of this stuff, any of the agenda, or any comments on that? Seems pretty straightforward. Okay. Then, Bernie, do you want me to share the slides from here?
Sure, yeah, if you can do that.
I can. All right, the floor is yours, Bernie.
Okay, so we'll talk a little bit about advancing DHCP v6 to Internet Standard. Can I advance the slides? No, I guess you'll do it. Okay, so the motivation for advancing DHCP v6 to Internet Standard from what it currently is, which is proposed, is really because of the charter. And the charter that we did many years ago, we figured it was a worthwhile endeavor to do, and that was also the reason we wrote RFC 8415, which really consolidated the base specification from the three core documents, 3315 and the two others, the IAPD and stateless, plus a few others, into a totally new document. But, we always have the choice to leave it as proposed, but I'm going to go on the assumption that the working group is interested in doing the work to move it to Internet Standard, because we are pretty close. So next slide. The requirements for an Internet Standard document is really 4 key criteria. There are at least 2 independent interoperating implementations with widespread deployment and successful operational experience. There are no errata against the specification that will cause a new implementation to fail to interoperate with deployed ones. There are no unused features in the specification that greatly increase implementation complexity. And 4, if the technology required to implement the specification requires patented or otherwise controlled technology, then the set of implementations must demonstrate at least 2 independent, separate, and successful uses of the licensing process. So let's go through each of those to indicate where we are today. I think there's no disagreement that we have lots of independent implementations that are interoperating today. Pretty much we have things from cable modems to home gateways to routers to servers to laptops, even quite a few handheld devices, mobile devices and things like that, all seem to be able to interoperate and work and do the DHCP v6 standard. Everything appears to operate well from both the previous USG v6 testing that was done at the UNH Interoperability Lab and previously at Cable Labs, field deployments like Comcast's broadband service, which is IPv6 based, and also things like the IETF MIDI network offers DHCP v6. So I think we have quite a lot of good implementations and have no issue with that. We do have 3 reported errata. And, we do have some unused features that could be argued to add some complexity, such as the IATA. We have no updated by that I could find, but that might be something to look through a little bit more carefully. And obviously there's no IPR that's been filed or that anybody has claimed regarding RC8415 or its predecessors that I am aware of, and has been reported to the IETF. There could be some issues in the documentation in the standard that we might not have had reported. If anybody is aware of any, please file an errata ASAP. The mailing list, I did do a quick sort of scan of it, does seem to have one minor item, and that is that there was no reference to RC 7943, which is in section 13.1, which talks about address predictability and algorithms to use to select addresses. And I think that was just a timing issue, because while we were sort of head down and writing the documentation, we missed updating RC 3315 and its friends to 8415. We kind of missed that this came out and should have been included. So that's a pretty minor thing, just to add another reference. Let's quickly go through the errata, because those are potentially sticky items. One is just a typo where section 6 is missing a closing parentheses. I don't think that causes any interoperability issues. And depending on what we do, if we do a 8415 biz, and if we drop temporary addresses, the section would disappear anyway, so it might be a non-issue to begin with. And we do have another typo in section 1838, which uses the word client instead of server. It's like it's talking about what the server does, and it says the client generates a packet. Well, no, it meant the server generates a packet. I think it's easily understood to be a typo, and probably is not that significant. Yes, it should be fixed, and we'll do that should we need to. Then we have this errata, which is a bit more involved. And this is an inconsistency as to whether server unicast can be used by information request messages. And it seems like the intent was that they could. And so there are a couple of sections that have some incorrect list of messages where information request message should be removed or included. There's also an inconsistency as to whether server unicast option can be used in a reconfigure message. So that would be another one to look at. There was some discussion on the mailing list about this issue. This could arguably cause some interoperability issues, although I'm not sure that it really has to date. But if a client were to use a server unicast in an information request and the server disallowed it, then obviously the server is going to probably send back a malformed or drop the packet, and therefore no progress would be made by the client to get an answer to its information request. So this one probably does require a correction, and that would be done through a biz document.
Okay.
And then, we have this kind of came up during the 8415 discussions about should we deprecate the IATA, since most clients never really use it. And, it kind of has, with most things being, if monitoring is being done, it's probably using the prefix, the /64 or something like that. And so the address itself doesn't really matter that much. And a client can always just go ask for another address if it wanted to anyway. There is one subtle distinction between an NA and IATA, because an IATA should not be put in DNS, for example. So if DNS updates are being performed by a server, it should not be doing an update for an IATA. So this is a discussion that we need to have in the working group as to whether we should deprecate this or not. And the other question is, are there any other things in the document that might be considered to obsolete? We did obsolete some things from 3315, and I don't think there's anything else, but it is a question. Next slide. So as I kind of mentioned, the errata likely requires a document update. We'll start with the co-authors of 8415 biz, assuming that the working group does want to proceed with this work, to start putting together the 8415 biz document. Depending on what the response is, or if somebody has a really strong desire to become involved, that might be something that the remaining co-authors consider in working on the biz documents and who would be included. The work is fairly small to integrate the errata. Removing the IATA temporary addresses is likely a bit messy. I mean, it's pretty straightforward, but there's quite a few places where the text would get some sort of changes. I think there's also an opportunity to shorten the document, which might be a little bit more palatable for the IESG when they have to go review this or the other people within the IETF that need to review this document. We can remove a lot of the motivation for the original RFC 8415. Some of the appendices were fairly large because we made a lot of changes and documented all those changes. And, obviously now we would just document what is new to 8415 biz from 8415. One of the goals is to be very careful to minimize the changes, though, because that will make our job as a working group to review the document much simpler. When you look at the diffs, you'll be able to say, yeah, I can see that the errata were corrected and other things were done. So this is my straw for what I think is a fairly aggressive but doable schedule, and that would be to publish an updated biz 8415 biz document, a 00 version of it, before the November IETF deadline. Again, it's not a lot of things to do, but there are a few things that the working group and the authors need to discuss about what do we do, both for fixing the errata and for removing the IETAs. The working group needs to do a good job at reviewing the document, because hopefully we can complete that a couple of months, 2 months later, and then publish the updated document by the March IETF deadline to submit it to the IESG. One other thing is that Tim is a co-author, I'm a co-author, and so we'll likely need to find a shepherd, as the co-chairs will be involved with the document, but I'll leave that up to the AD to decide, and maybe one of the ADs would even be willing to shepherd the document. So the first big question is, do we go for it? Do people think it's worth advancing this to internet standard? So I don't know if you want to take a straw poll, Tim, in the room to see, and don't we have a voting tool, don't we, here?
Yeah, I'm putting one up.
Show of hands tool. Yeah.
Yep, I'm working on it.
Okay.
Should have been doing that earlier.
Okay.
That's a pretty good response.
Yeah.
Okay, so I think that's definitely an indication. I mean, obviously we're going to go to the list with this, but I think that's a sign that people are interested in doing this.
Yeah. And I don't know, is everybody in the room there, or is that just an online participants? Okay.
It's both. Yeah, that's how it works. We do have somebody wanting to come to the queue.
Okay.
Hi, Mike Ackerman. My question is about IATA, and with the focus on security, which that is intended to do, I think, why would it be a good idea to take that out now? And I know you're going to say nobody's using it, but the folks that would use it the most would be enterprises like myself, and we're not doing anything in IPv6 yet. But when we do, this could be important. So I guess that's my question.
Well, and that is really the debate. It does add a little bit complexity, and since its usage has been found to be almost zero, Microsoft at one point was using it. I don't know whether they're still doing so. I mean, maybe that's that's a discussion that the working group should have, is, do we know of implementations out there using it, or do we know of people potentially interested now or in the future in using it?
Yeah,
and I obviously apologize. Go ahead.
I was going to say, the case I'm making isn't for anybody using it. I'm saying some of us might use it in the future, and I know that's not a very strong statement, but it's all I got right now.
Right.
Okay, just my 2 cents. Thank you.
Thanks. I'm going to close that poll.
Okay, so I'm just going to...
Suresh, come on up.
Oh, yeah, I've not going to change.
Go ahead, Suresh.
Okay, thank you. So, Bernie, just a couple of things. I think one of the things I'm really worried. Thanks. So one of the things is really like, this is like a really long process, and if you're going through with this, I think there's like some other stuff we need to look at. So there's like a couple of things that kind of caught my eye, right? Like, like some of the late RFCs, right? Like, Solmax RT and stuff like that, right? Is somebody using it, right? Like, I think, Tim, you would know best, like among all the people, right? So maybe to also go over like a lot of the, when I say newer, like probably like last 10 years, right? Like all the stuff that came out, right? Like, bulk lease query stuff, right?
Yeah.
To see
Well,
what
so,
the,
yeah, so the bulk lease query, just to say, is that's a separate RFC and not covered in the base 8415. But things like the information, sorry, the solicit refresh timer and things like that, those are in there. And yes, we do, I do know that there are devices out there using that, and they seem to work.
okay.
So,
Yeah.
but yeah, I
one
mean,
thing
I
to
think,
just, yeah.
I think we
ahead, Lee.
need to, and I think Tim may have some stuff to say about the USG v6 stuff, because some of the testing there on the new DHCP v6 8415 work focuses on some of that additional testing.
Yeah, so I'll talk a little bit about this and kind of make a plug for my friends at the UNH IOL. So what we've, the Ready logo has a new DHCP logo we're working on. We put it out for public review. I said some notes about this on the list. The general idea there is to cover all of the new things that got included in 8415, like Solmax RT, stateful issues, a couple of those things that weren't in a 3315 standard client or server. So one thing, if you're interested in my call kind of here would be is if you have an implementation and you're interested, please talk to my friends at the IOL, drop it off there. They're just looking for interoperability partners to make sure that people have implemented some of those more corner test cases, because there's a little bit of concern. I'm hoping by November we'll have better results to say, yeah, we've got a bunch of people that have done this. I think we're kind of in a state where I think some of it's been done, like Solmax RT is in the home gateways for sure. But I don't know what it looks like for enterprises, for example. So I think some of that we're going to have to sort out.
That makes sense, right? I think the idea would be to kind of make it easy for Eric to kind of defend this, right? So if the information is ready to go, I think it's easier for him to like defend something that Eric would say like, hey, like, this is where it's implemented and so on, because like we kind of remove the implementation status and everything from the RFCs, right? So it'll be good to kind of have this information ready, because this is a really long process. And I did 8200, like, and it's like, and it's like really tough on the AD. So it's probably good to kind of have a good idea of like, what is really out there. Like,
Okay, thanks. That's good to know.
Yeah, we probably need, we'll probably need to develop some kind of feature matrix or something to see, have these combinations been tested, especially about some of the newer non-basic sort of stuff. Yeah. So, what can you do to help in the short term? Well, for the co-authors, I need to hear from you whether you're interested in working on this or not. And if anybody else has a strong interest, let me know. You can send to DHC chairs if you are interested. That way Tim's aware of it as well. And the other thing is, if you have any issues that you've had with RFC 8415, any typos, errors, more severe mistakes or whatever, do report them. Ideally, it's best if you report them as using the errata stuff. But if you don't want to do that, you can send them to DHC chairs at IETF.org for now, as we'll collect them. We might, depending on how the DHCP V6 biz team wants to work, we might open up a different mailing list as we kind of did last time. But I think this is hopefully a smaller effort, and we won't need to do that. The other thing is that, it's again something in the future, but we need people to review the document when published and do it promptly. And, give us updates quickly so that we can get new corrected versions out as soon as possible. So that's it.
Awesome. Thanks, Bernie. I think we got our next steps here, so we'll take some stuff to the list for sure. All right. Let's see. Next up is the DHCP SR locator. Let's see. I'll put up the slides. All right. Let's see. Okay, you want to go ahead, Wing Chang?
Yeah, so hello, Chair, could you hear me?
Yep, we can hear you just fine. Go ahead.
Okay.
You want me to give you control of the slides, or you okay if I do it?
I can do that.
Okay, hang on.
Okay, so hello everyone. I'm Wu Changcheng from Channel Mobile. I will present this slide to show the distributed SRv6 located by DHCP. And okay, so here the figure shows the network architecture of telecom operators. The application scenario here is private line and VPN services for enterprises. The CPEs are located in the customer's sites. The number will be very large, even more than 50,000 around the country. With a wide geographical distribution. Some of them may be based on 4G or 5G with a high mobility. In order to keep the network simple, the CPs often do not deploy IGP. So recently, many operators have deployed large-scale SRv6 networks. The CPs also began to support SRv6 so that operators can provide the end-to-end SRv6 VPN to customers. It's a little bit complicated to configure the SRv6. We hope to simplify the configuration and hope the CPE can dynamically learn SRv6 locator subnet routines. That's why we raised this proposal. The proposal is very simple. The basic idea is that we treat the SRv6 locate as the IPv6 prefix in prefix pool. The key points are here. The first one is the DHCP v6 server allocates SRv6 locator as a prefix. The second, follow the DHCP v6 prefix delegation process. And the third, after the locator prefix assigned successfully, the BIOS dynamically distribute the locate subnet routine locally and distributes the local the locator subnet routines to other nodes in the network. And the fourth, when the locate prefix is released, the BIOS deletes the locate subnets routines. Here, the BIOS need to enable DHCP v6 PD server or DHCP v6 relay agent service. So before we introduce the DHCP extension, I would like to share the basic information about the SRv6 seed format, especially the comprised SRv6 seed format, which is illustrated in the bottom of the slide. For the comprised seed, the locator will be separated to two parts. The common part, we call that locate block, and the different part, we call that locate node. Other field are the same with the original seed, which defined in RFC 89, 86. So about the extension, we hope to define a new SRv6 locator option. It will be encapsulated in the IA prefix options field of IA prefix option. It will be used to identify SRv6 locator prefix in IA prefix option and carry SRv6 locator subnet information. The format shows in the figure. Firstly, we need a new option code for the option SRv6 locator. The second, we will have a locate block length field that indicate the locate block, the length of the locate block in a comprised seed if it's not 0. If it's a 0, it will indicate an original SRv6 seed. And we need a function length field, which indicate the length of function. We need an argument length field. It will indicate the length of the argument. That's the basic extension. Here, the SRv6 locate prefix is filled in the IPv6 prefix field of the IA prefix option. The locate prefix length is filled in the prefix length field of IA prefix option, so that you can calculate the locator node length based on the information here. So all the length of the field for the comprised seed or for the original seed can be generated based on the information in the extension header. And this is the basic relationship for the SRv6 locator option. I think it's very simple. And IAPD option may contain multiple IA prefix options at the same time, and an IA prefix option can only have one SRv6 locator option at most. This is based on the IFC 8415. And let's see some application scenarios. The first one, the BIOS works as DHCP v6 PD server. At this moment, the behavior second, generate the locate subnet routine locally. The third, distribute the locate subnet routine to other IPv6 node. So it's very simple. And the second scenario, BIOS works as DHCP v6 relay agent. It's also very simple. The behavior like that. First, relay DHCP v6 PD allocation messages. The second, generate the locate subnet routine locally. The third, distribute the locate prefix routes to other IPv6 node. So that's the basic behavior for a relay agent. So that's all. Any question or comments?
Bernie, I think you beat him in line, so you can go ahead.
Okay.
Trying to touch.
So, if a client sends this new option in a request or, solicit and things, and a server that's aware of this option would send one in a reply. So the client can know, oh yeah, okay, the server understood this. But if a server that doesn't understand this new option, it will respond with a prefix because it's just going to look and say, oh, see, I see a request for a prefix. So I'm going to assign you a prefix. And so now what does the client do with that prefix that it got that it's not, it doesn't have your new option in it, the SRV or whatever it was called. SRv6 locator option in it. So the client would go, well, this isn't an SRv6 thing. So is the client going to turn around and release it? So I think that's something that needs to be thought out is how does a client make sure that when it asks for one of these things that it knows it got one, and I think you've got the check on that. But how does it know, or what does it do? How does it deal with it if the server didn't know about this SRv6 locator option, and just assigned a prefix from its prefix pool?
Mm-hmm. So I think this is a very good question. So from my point of view, for the server, if it doesn't know the option, it will ignore the new option, right? That is a basic behavior for the server,
Right.
which to handle the new option. And it just treat it as the original prefix allocation. That is okay.
Well, the server doesn't understand the option. It's going to allocate a normal prefix, right? And you've wasted a prefix potentially because the client can't use it for the SRv6 purposes, right?
Yeah, that may be that may happen, but you know, this system will be maintained in one operator's network. I think it's easier to generate some basic policy to avoid the, this kind of problem.
Well, I think for interoperability reasons, right, you should, it's, I mean, you can't so argue this is a closed system, right? People can plug things in and stuff. So I think you need to think about how to deal with that. You know, I mean, one thought maybe that you want instead of putting it in a standard prefix option, maybe you want to add a new, you know, IA SRv6 option, right? Which says, hey, this is an SRv6 locator, you know, so you want an IA option for this.
Yeah, that's possible. I think we should consider the question later, and hope we can handle it. Thank you.
Yeah, and you know, I'm not going to. I can't say whether this is a good or bad idea because I'm not really an SRv6 expert, and so you know, I think that it will be good at some point to get some input from some people that have more of this experience because and you know, I mean, this is a protocol option probably especially if it's an IA. And so it should be done in the DHC working group, but we are going to need some expertise to help us.
Yeah, maybe we can also submit the draft to Spring working group, and maybe we can also apply some slot in Spring working group to present it and to see the feedback and comments.
Okay. We got 15 more minutes. Let's let Eric and Suresh say their.
Yeah, Eric Quinn. I'm going to run real quick, actually, because I think Bernie said everything I wanted to say.
Okay.
I'm just going to say, I think the DHC idiomatic way of doing it is probably to define a new option, which Bernie suggested. I'm going to go ahead and guess that the reason that maybe you didn't propose that is because the BRAS might not be able to be updated. I don't know if that's a really good reason or not. And secondly, as well as temporary delegated responsible AD, I was going to say it definitely does have to have review from Spring.
Yeah.
And
Okay.
if we adopt this work, we also need, you know, permission from our AD.
Yeah,
I would suggest those are co-temporaneous.
Yes.
Thanks,
okay.
Eric.
Okay, thanks.
Okay, I think that's everybody. Okay, great. Thank you.
Thank you.
Let's see. Jen, I think you're up. Well, I'll let you two work this out. Whichever one of you wants to get up here. I feel you, Warren.
There we go. Doing it with my hat on. The whole like AD hat thing doesn't. Yeah. Okay. So, hi everyone. My plan was that I was going to be in the Grow working group and Jen was going to present this. So I am in no way prepared. So I'll make this up as we go along. So this is registering self-generated IPv6 addresses using DHCP v6. And thank you. This is who we are. The draft is actually based on an earlier document from Suresh and Rajiv and some others. But it's myself, Lorenzo, Jen at some point. So that's us. Next slide. Why are we doing this? Because eventually asking people, have you tried turning it off and on, gets really old. So what are we trying to do? What's the problem we want to solve? So a fairly common thing with like IT help desks and security people is they need to do things like find what IP address a machine has. With IPv4, the CEO can't print to his printer. He calls up and he's really annoyed. People look in the DHCP logs. They find the IP address based on the MAC. They ping the printer. They, things work out and they're happy. If you're doing IPv6 with Slack, the CEO calls up and says he can't print to his printer. And you say, have you tried turning it off and on again? And he says, yes. And you say, have you tried turning it off and on again? And he says, yes. And then you go post your resume on Monster, right? If you just have the MAC address, it's really hard to figure out what IPv6 address somebody has. Next one. The other common use case is security operations folk have something where, last Thursday at 2:43, they have some IDS log that shows that some machine uploaded their entire source tree to Stack Overflow. What they'd like to know is which employee had this IP address at this time, or what machine had this IP address at this time. With IPv4, the obvious thing is you have the IP address, you go look in the DHCP logs, you find the MAC address, and then HR goes along and visits the employee and says, you did what? With v6, what you say is, that's not good. I have no idea who used that address. They assigned it to themselves with Slack. And then once again, you post your resume on monster.com. Next slide. So obviously, the problem is that a lot of people, a lot of devices run Slack and don't use DHCP for doing address assignment. That's actually what's happening on this network. When your machine joins this network, you do Slack and you get an address, and the network doesn't really know what it is. Like the network devices do, but there's no central tracking of it, anything like that. An option would be, tell everybody you should do DHCP for address assignment. That doesn't always wend well. It doesn't look like it's going to happen. So what are we actually proposing? As I say, this was based on an earlier draft, which was Suresh, Rajiv, and I can't remember who else wrote it. Sheng, yep. Which was basically registering self-generated IPv6 addresses in DNS using DHCP v6. And it went along fairly well, but then it got stuck in working group last call. And as far as I can tell, almost all of the unhappiness was about the DNS part of it. So how do you take this address and authenticate it that this client should be able to update that DNS address? So what we did is we took out all of the DNS bits and made a few other changes. And what we're left with is a method to inform a DHCP v6 server that a device has a self-generated address or a statically configured address. What this does is it allows the DHCP server to log this information and ideally also stick the information in its leases file so that it knows, or leases database, so that it knows that the address is in use and it doesn't try and hand it out. In reality, that's not likely that big a problem. The chances of multiple people choosing an address and a DHCP server trying to assign it are fairly low, but it's still useful. This solves the help desk use case when the help desk wants to figure out what IP address a certain MAC address has. it looks in the DHCP logs. It also solves the SecOps problem. If they want to know what MAC address and IP address was a while back, they look in the logs or what other sort of tooling is around the DHCP server. The way it does this is it's fairly simple. There's a DHCP v6 address notification message, which just says, hey, I'm using this address. Please make note of it. Does this actually solve the SecOps problems? Well, only kind of. Because of reasons, what you actually get with DHCP v6 is you get the DUID.
Yeah.
And that's a whole site better than nothing at all. Often it is actually based on the MAC address, but not always. If it's a device that your security group has heard about, there's a reasonable chance they could actually like log the DUID in an asset database. And if they don't do that, there's also client link layer address option in DHCP v6, which a number of network devices implement. And so that information shows up in the log. I tested it actually with iOS XE on the IETF Wi-Fi network. DHCPD and Microsoft seem to support it. Or there is what I think was being discussed when I first walked in, which is a update to 6.2.1, where a bunch of BNGs and BRASs and similar can include, the address in the message. I wrote these slides a long time ago. Yay, the next one's questions. So I made up most of the talk on the fly. Who has questions? Or is this the best idea ever?
Bernie, you were up there, I don't
Is
know.
it the worst idea ever?
Yeah.
Okay.
Well, I don't know. I'd have to go back to the notes about why we didn't like it that much in the first place. I guess I just have one question, and that is that, if a device were to remove itself from the network, it's not defending its address, and another device comes along and registers it, you're just going to say the DHCP server basically has no responsibility just to say, hey, I got an updated thing. It's a totally different client, but I'm going to record it. That's
Yep.
sort of
So,
what you're
yeah,
expecting.
Yep. At the moment, it is purely the client sends a message that says, I'm using this, and the DHCP server logs it. If
Okay.
another client comes along and says, I'm using this, the DHCP server logs it.
Okay.
It's just I get this, no useful sanity checking. So clearly there are some ways this could be abused, right? Like people could say that somebody else was using the address. Attackers could also, if they wanted, never send the message, like even if it's built into their OS, if they wanted to hide who they are, when they join the network, they could suppress the message from being sent. But I still think it's a lot better than not having any information. So sort of a perfect versus the enemy of the good type thing. Did that actually answer your question, or did I answer a completely unrelated question?
No, that's good.
Kathy's going to tell me why I'm wrong.
No, it's Vicky, not Kathy, but you're close.
Wow,
But,
did I really just call you Kathy?
That's okay.
My God, I've known you forever.
I'm
Sorry.
flattered. So that was mostly what I was thinking, but this is just a fire and forget thing.
Yes.
It sends that there's no consequence, there's no acknowledgement required.
I believe that you're supposed to get back an ACK, but you don't have to. I can't remember if we had the ACK in the end, and you send a couple, and Jen's going to correct me.
As far as I can remember, what we're doing, we're saying that you refresh it periodically.
Yep.
And actually, draft has two conflicting sentences currently, and we have a Dhcp issue for that. But I think we discussed the idea of ARC and decided not to, because you never know if your server actually understands that.
Yep.
So, and we also only require the client to send this if there is a M or O bit set in array, indicating there is a DHCP server, because I definitely don't want clients to send those messages if there is no DHCP in the network, whatever. So, but client still has no way to know what server actually supports. So just, I'm sending it, if you're happy to log it, or drop it. Yeah, it's stateless. It's the whole idea, like client like willing to inform server and server willing to do whatever.
And I guess
Okay.
there's no security concern about just
Nope.
sending off information.
Well, it goes like if you send an array with MOO, you kind of indicating to client there is a DHCP somewhere. Client sending it to all DHCP link local multicast. So again, if there is no such thing on the segment, it will just go nowhere. If there is a relay agent, it means the network operator kind of expects something
So
like
does
that.
this time out at some point, or does this lease just as a permanent?
It times out. We have some, sorry, I'd actually misunderstood your question. I thought it was I'm using this address and the DHCP server can say no. So I misunderstood your question
Well,
on
I'm
that.
just really wondering what the responsibility is of the
The
DHCP server in this.
The
Is really my
DHCP
only
server's
concern.
responsibility is log this, optionally note it in sort of your, wherever you store lease information. And so you don't try and hand it to someone else.
Right.
That's optionally.
But you just
It's-
put it
yep.
in there and it stays in there
You
forever.
stuff it, nope, it times out after an amount of time.
Oh, okay.
The exact amount of time the authors are still fighting over, we disagree.
As long as it times out eventually.
Yep, it times out eventually.
Okay.
It's like, does it time out in 4 hours or a day or whatever is the like deciding the best answer for that's a bit tricky, but it times out. It's not infinitely growing. It's also if, for example, your disk gets full, the DHCP server is allowed to throw them away, or if it's having a bad day,
Okay,
it's a best use only.
That was exactly what I was thinking about is, getting basically DDoSed by a bunch of goofy clients just sending stuff that you don't even care about,
Yep.
that then you have to keep. And
Yep. You're allowed to ignore them if you feel like it. And yes, they will time out. Part of the thing is there's like 17 different timers that we could base the timeout on. And is it like the lowest of this one unless it's more than X versus, so the exact numbers, the bit we're wibbling over. To be decided, actually. That sounds better. Any other?
Yeah, we got a couple more. We got Hazel, you're online.
Hi, Hazel Smith. I was wondering if this did have an ACK, then conceivably you could, if you were designing, access switches, you could use this sort of IP source card v6 and basically say like, if you've actually got a lease from DHCP v6, you can use this address. Or if you've sent an announcement saying, a notification saying, I'm going to use it, and the DHCP server responded, sure, fine with me, then you allow it. Otherwise, you don't, which would then give you some kind of assurance that, that if you later see packets on the network with the IP address, that they came from the device with the MAC address that had told you it was going to use that IP address. I've no idea if that would be a valuable concept, but
Yeah, thanks, Hazel. Like, I think one of the worries is that, right, if the DHCP server doesn't support it and you're waiting for like the DHCP server to say it's okay, like that could lead to like, somebody not having access to that address, right? That's the worry. And that's why it's kind of going as best effort to go through. But I think it's like fairly valuable if you have like a control system and this is something that it's going to happen. We can probably like, set up something like RA guard kind of thing, right? It can hook up to something like RA guard to do that. But otherwise, like it's going to be a bit tough to like lock it down too much, right? This is best effort. Yeah.
So
Can I quickly just follow up on this? There is another concern. We expect the client only report preferred addresses, which means by the time you send this, applications might already want to send traffic. So if you want to do something like Savvy, it's better to use DAD or unsolicited NAs or any other form of client willing to get an address. And it might be way too late here to do anything based on DHCP registration.
and I guess I'll add something to that. Like one of the other bits on my badge is like Knock Monkey. And we've been having a lot of entertainment at this meeting with IPv6 and DAD and the network devices going, oh, I don't think you should really have that on that port. I mean, actually what it's doing is it's sending its like device tracking message from : because of entertaining bugs. So like your switch can do MAC address learning and locking down just as like terrifying, but that's my personal. Vendors love it.
Okay, we got 1 minute left. Eric, you want to?
Yeah, Eric Kinnear, I just wanted to say that doing this for anything other than purely informational purposes, like as tempting as it is and as fun as it is to be like, hey, I should take this into account when giving out leases,
Like, it seems like there's a huge can of worms to open there. So
Yep, purely
here's a
informational.
centrally known place to log stuff is like, cool, great, have at it, have fun, log as much as you feel like. If it's too much, just start ignoring them.
Yep.
Yeah.
Everything else starts to seem sketchier and sketchier.
Thank you very much.
We have, go ahead. We got one more person. We're going to sneak in here in the last 30 seconds. Go.
So have you thought about perhaps routers or other network devices faking these messages to get a more populated log?
Sorry, to get a more what?
To get a more populated log. So also log clients that are not collaborating.
Yeah, somebody suggested that. You know, a device that sees somebody using a Mac and IP could send this. I think that that sounds like a really bad idea. Mainly because it seems like a lot of complexity. Like a router could be like, I saw this guy using this IP and Mac, I'll send it off. I think that bad mojo, but it could be done.
All right, awesome. I think we've got some good stuff to talk about here on the list. I think that's everything we had on the agenda. Does anyone have, Bernie, do you have any last things you want to chat about?
Clicked the wrong thing. I clicked the hand instead of the mic. No, I don't have anything else.
Okay, awesome. Okay, great. Great seeing everyone. We'll see everyone in London again. We'll follow up in the mailing list. Thanks, everybody.
See you, Bunny. Nice seeing you.
Okay, yeah, good to see you guys. Take care. Enjoy.
Thanks, you'll take care.
Thanks. Bye-bye.
Hey, Ben, can I talk you into reviewing 8415? I do.